In this lesson, we will cover questions from Unit 7, Section 7.2, Solving a System of Linear Equations Graphically. Question 1. Which graph represents the solutions of the linear system y equals negative 2x plus 2 and y plus 6 equals 2x? So our best place to start here is to take each of these equations and write it in slope-intercept form. When we do this, we can clearly see the slope and the y-intercept. So the first one is already in slope-intercept form, so that helps us a lot. But what we have to do with the second equation is subtract 6 on both sides. So that will give us y equals 2x subtract 6. And on the other hand, our other equation would be negative 2x plus 2. So we're looking at an increasing function here that will have a y-intercept of negative 6 and a slope of 2. The other equation will be a decreasing line with a slope of negative 2 and a y-intercept of positive 2. So what we're going to do first, we're going to look for the equation that has a y-intercept of positive 2 and is decreasing. So if we look at graph A, this does indeed have a y-intercept of 2, so this could be an option. Graph B does not have a y-intercept of positive 2. It actually has positive 1, so that is gone. Graph C is also eliminated because it has a y-intercept of 4. Graph D also has a y-intercept of positive 2 on a decreasing line. So we have options A and D left. So we have this one here, we checked the decreasing line with a intercept of 2 and negative 2 slope. So what if we look for a line now with a y-intercept of negative 6? So this one here has a y-intercept of negative 6, and this one does not. It has negative 5. So the solution is actually going to be A. We can always check that by taking the x and the y-intercept, the point of intersection, and we can take those x and y coordinates and plug it back into both equations to ensure that the left-hand side does equal the right-hand side. So 2 times positive 2 is 4. 4 subtract 6 is negative 2. That's correct. Negative 2 times 2 is negative 4. Negative 4 plus 2 is negative 2. Again, that is correct. So our solution, graph A, is fine. Question 2. Solve the linear system graphically. We have 2x plus 4y equals negative 8. And 3x subtract y is equal to 9. So we're going to take both of these equations now, and we're going to rewrite them both in slope-intercept form and graph it from there. So first of all, we're just going to get it into y equals mx plus b form. So we have 4y equals negative 2x subtract 8. We're going to divide everything now by 4. We will have y equals negative 1/2 x take away 2. So right now we have a negative slope. We have a decreasing line with a slope of negative 1/2 and a y-intercept of negative 2. Our second equation, 3x subtract y equals 9. We're going to take away 3x on both sides, which will give us negative y, which equals to negative 3x plus 9. Of course, we're going to divide everything by negative 1. Y equals 3x subtract 9. In this equation, we have an increasing line segment with a slope of 3 and a y-intercept of negative 9. So we're going to start off with negative 9 here. We're going 3 for the rise, and run will be 1. So 1, 2, 3 over 1. 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 We're just going to continue this process a little further. Okay, so we'll start increasing line as you can see here. Next, we're going to start off with our intercept of -2, so -1, -2. And this graph is going to go down and it's going to go over 2. So we're going down 1 and over 2. So right away we already have our point of intersection right here. So it's going down 1 over 2, down 1 over 2, down 1 over 2. So right here, this point is our point of intersection. So let's see if we can try to neatly join up our points. Very difficult on the graph here. So let's try to Of course, when you do this question yourself, you will have a ruler and your lines will be much better. So our point of intersection here will be -2 and -3. And you can actually take those 2 points and plug it back into your question and make sure that the left-hand side does indeed equal the right-hand side.